Okay, the next one is like numbers 26 through 28 on your review. You've got a combination of functions. I've got sine, cosine, inverse, but it could be any, any combination of trig functions here. So the key here is to remember that the inverse function is going to give you an angle, and you can set up a triangle from that. So this is going to give me an angle. Anytime you have an inverse function, the answer is an angle. And then what I'm actually trying to do is find sine of that angle. Okay, so this part right here with the inverse, that tells me that hold on one second. I don't know why I wrote that. Okay, that tells me that cosine of theta is equal to 12/13. That's what cosine inverse means. So I can set up a triangle from that. All right, so there's my theta. You can set yours up, either way. Cosine is adjacent over hypotenuse. And we find the missing side. You might recognize this as a 5, 12, 13 triangle. If you don't, that's okay. So we would have, I don't know, let's call that A. So we'd have A squared plus 12 squared equals 13 squared. And we would find the missing side. So I'm going to have, A squared plus 144 equals 169. Sorry, I'm going to go sideways here. Well, actually, let me fix this. There we go. Sorry, I didn't leave myself enough room there. Okay. All right, so we'll finish this. Move the 144 over. We get A squared is 25, and take square root on both sides. We get that A is 5. Okay. So if you recognize those special triangles, you can skip that. But if not, it's fine. Just do the Pythagorean theorem and you get it. All right. So this inverse function sets up our triangle. And then what we're trying to find is we're trying to find sine of that triangle or sine of that angle. So now you look at your triangle and you remember sine is opposite over adjacent. So that's going to be 5 over 13. Okay, so 5 over 13. Okay, so the key to these types of problems is to set up a triangle. All right, the last two, I didn't write what they are on the review sheet. I apologize for that. They're whatever the equations and inequalities are. That's what we're doing. That last group of problems. I think it's 29 to 33, I think, are the problems here. I'm not sure where it ends. It might be 35. All right, so the first one is an equation. We've got cosine x equals sine 2x. So we talked about this week in the live session. So you're looking for a couple different things. You're looking for a linear one, which means a function by itself. We don't have that here because we've got a cosine and a sine. We're looking for a quadratic. So we've got something squared and then that's something. So like cosine squared and cosine. We don't have that here, at least not yet. And you're looking for a common factor. So like cosine in both terms, sine in both terms, tangent in both terms. So we don't have any of that right now, but we do have a double angle here. So let's go ahead and write out that double angle and see what we have. So we would have cosine x on the left. Sine 2x is the same as 2 sine x cosine x. And now we see that both terms have a cosine. So we move them to the same side. It does not matter which side you move them to. So if I move them this direction, we're going to have 2 sine x cosine x minus cosine x. So we move them to the same side, and now we can factor out the cosine. So we're going to have 2 sine x minus 1. Got something times something equals 0. That's what we want to break this up. So I can break this up as cosine equals 0 and 2 sine x minus 1 equals 0. And we should be able to solve these. So you look at your unit circle or on a graph to see where cosine is equal to 0. That's going to be at pi over 2 and 3 pi over 2. We're solving on 0 to 2 pi, so I'm going to stop there. And then this one, we need to solve a little bit more, so we're going to add 1 and divide by 2. And we're looking for sine x is equal to 1/2. So again, you look at your unit circle, or you might even remember these by now. That's going to be pi over 6 and 5 pi over 6. I am not looking at a unit circle, so you guys check me on that one. All right. So for a lot of these, you're going to get multiple answers. So don't just stop if you get 1 or 2 answers. You got to make sure that you get all of them. So keep going all the way to the end. Okay, so that's an example of an equation. You're going to look for the same things that you knew in college algebra, like common factors, trinomial factors, linear style equations. All right, so the next one we got a trig inequality. So we've already got everything on one side of the inequality, so that helps. So let me just rewrite this. All right, we've got square root of 3 sine x minus 2 greater than or equal to 0. So remember the two things that we need to do. We need to find the intercepts. We need to find where it equals 0. And then we need to look at the inequality. Since it's greater than, we're looking for where it's above the x-axis. Okay, so greater than is above, less than is below, and you have to have a 0 on one side. Okay, so our first step is to figure out the x-intercepts. So that is where our function is equal to 0. Okay, so we're going to do this just like we did number 9. Set this equal to 0 and solve. So we're going to move the 2 over. And we're going to divide by square root of 3. I think I have a typo here. I do. All right, we're not going to be able to solve it in this form, so I apologize. We're going to back up. It's going to be the same exact idea. I just need to change the original problem. Sorry. Okay. This needs to be 2. This needs to be square root of 3. I apologize. I had the original problem wrong. Okay, let's try this. This should be much more doable. Okay, same idea. So we're going to find the x-intercepts. If you had yours written out, just switch these two numbers. I just couldn't do that easily. So we're going to set this equal to 0. And we're going to solve, and we're still looking for above. That part didn't change. Okay. All right, so we're going to solve for sine. So we've got 2 sine x equals square root of 3. Divide both sides by 2. And we get sine x equals square root of 3 over 2. So we're going to look on all the places 0 to 2 pi where that happens. So you're going to look at the unit circle, and you're going to get that x is equal to, that's going to be pi over 3 and 2 pi over 3. Okay, now, that was a lot of work, so you might feel like, whew, I'm done. But that's not. That's just the x-intercepts. Okay, so these are the x-intercepts. And we go on to step 2. So step 2 is to graph this and see where it's above the x-axis. So let's go to the graphing calculator and graph it. Okay, so here we're in the graphing calculator app. Should look like what you have. And we're going to put the function in. The original function was 2 sine x minus square root of 3. Okay, so that's the original function. If you have not adjusted your windows like we did in class, you want to take your window and I would do 0 to 6.5. We did 7 in class, but that was pretty big, or like maybe 6.4. You want to go 0 to 2 pi. So 6.4 is 6.28 is 2 pi. So 6.4 is good. And then your y minimum and maximum should be negative 10 to 10. Let's just go ahead and reset that to the normal one. But if you have this adjusted, it shouldn't matter. Okay, so this would be the standard settings for the window when you're graphing a trig function, 0 to 6.4, and then negative 10 to 10. And we hit graph, and that's our picture. So if you want to zoom in a little bit to see what's going on here, but you should be able to see where it's above and below. If you want to change your window, you can. So let's say we go like negative, just to zoom in a little bit here, we can do like negative 5 to 5. So you can kind of play around with that, and that way you see a little bit better where it's above and below, so I can see a little bit better what's going on here. Okay, so let's go back to our work. Okay, so we come back to our work and remember that we've already found the x-intercepts. So when I paste this graph in, the numbers that we have for our x-intercept should match our graph. So see that? This should be pi over 3, and this should be 2 pi over 3. All of the numbers that you found for x-intercepts should match your x-intercepts on the graph. There shouldn't be any extra, there shouldn't be any missing. Okay, so we have our 2. And then we scroll back up and we remember that we are also looking for where it's above the x-axis. So you look at your picture, above the x-axis is right here. Okay, so that red part is what I'm looking for. So I'm going to go from pi over 3 to 2 pi over 3. So writing the interval, we always go from left to right. And then I have to decide if I want to do round brackets or square brackets. So I come back up to the top. I see that it's included right here, greater than or equal to. So that means I'm included, and I'm going to use square brackets. If it was not included, I would use round brackets. Okay, and that's the only part of this graph that's above the x-axis. That's my final answer.